Dienone-phenol rearrangement is the acid or base-catalyzed migration of a carbon-carbon bond in a dienone to yield a phenol. In this video, we're going to talk about the reaction and its mechanism. So let's begin. Right, so you can see here we have this dienone molecule. We have this ketone functional group which has two double bonds on either side of the carbonyl functional group. So that is why it is known as a dienone. And at position 4, you can see that we have two alkyl groups. So this is a tertiary carbon, this position 4, and it has two alkyl groups attached to it. One of these alkyl groups has been shifted to position 3 and the overall molecule has converted to a phenol. And this reaction is acid catalyzed. So let's see how the mechanism works. So here is our dienone with two alkyl groups. Let me differentiate them by R and R prime at position 4, and this is an acid catalyzed reaction. So what will happen apparently is that this oxygen will be protonated gaining a positive charge, which will ultimately lead to the shifting of one of the carbon-carbon bonds due to readjustment or movement of these pi electrons accordingly. So what we get as a result is this moiety. We now have an R group here. This double bond is intact. We have a carbon-oxygen single bond. The positive charge is gone, and we have a pi bond here. And we have an R group attached at this position now. Because this R group has migrated in the form of a nucleophile along with the electrons. So this carbon, which was initially the tertiary carbon, has been left without electrons, so it gets a positive charge. A carbocation is generated here. And now you can sense what will happen. This carbocation has to be removed, and here we have a hydrogen which is lost in the form of a proton to get rid of this positive charge on the ring. And what happens as a result is that an aromatic ring is produced with this OH group. So a phenol has been generated. And so you can see that this dienone has been converted into a phenol. And it's a 1,3 migration. Dienone-phenol rearrangement can also be observed in bicyclic systems. For example, if you have a system like this, in which we have this dienone moiety which is fused with this ring, and we have a CH3 group here. Such type of bicyclic systems are usually found in terpenes, diterpenes, or even triterpenes, or steroids, right? So if you have like another ring here, a 6-membered ring, and then a 5-membered ring, so this forms a steroid. So the ring A and B forms this fused system in which this dienone-phenol rearrangement may take place if we have a ketone at position 3, which usually is there, or sometimes it's a OH group. And of course, we have a CH3 group in case of androstanes, or a hydrogen in case of estranes. So in such type of dienones, this dienone-phenol rearrangement can take place and aromatization is usually observed. So this is all about dienone-phenol rearrangement. Stay tuned for more named organic reactions in the upcoming videos. Thank you so much.